Have you ever wondered about this? Why is it that some cancers seem to just explode out of nowhere, growing with this terrifying speed, while other times they can go totally unnoticed for years? It's a huge biological mystery, and it has massive implications for how we actually fight this disease. So today, we're going to unravel that.
And this is really the core question, isn't it? If you think of cancer like an invading army, why doesn't it just use the same strategy every single time? You've got some cancers that launch this all-out assault, a blitzkrieg, right? And then you have others that go for a slow, methodical siege. Well, the secret to these different strategies, it isn't some big external plan. It's actually written right into the very code of the cancer cells themselves.
Okay, so before we can even begin to understand the chaos of cancer, we first have to appreciate the incredible order that's happening inside a healthy body. I mean, our cells, they aren't just some random mess. They follow this really strict set of rules for growth, for division, and even for death. It's this beautifully regulated system that keeps everything perfectly in balance.
And this slide really nails the fundamental difference. On the left, you've got your normal cells. Think of them like polite citizens in a super well-ordered society. They follow the rules, they respect personal space, and crucially, they know when it's time to stop growing. But on the right, well, there you have the cancer cells. They're the ultimate anarchists. They blow right past all the stop signs and just keep multiplying and multiplying, creating total chaos. So what is it that turns a totally law-abiding cell into a complete renegade? The short answer is mutations. These are tiny little errors in a cell's genetic code, and they basically hijack its internal controls. They slam the gas pedal to the floor by turning on things called oncogenes, and at the same time, they cut the brakes, our crucial tumor suppressor genes.
So let's be clear about what a mutation is in this context. It's not just some random typo in the genetic code. No, it's a very specific change that acts like a get-out-of-jail-free card for that cell, giving it this rogue advantage. This one change lets it bypass all the natural safety checks that are supposed to keep growth under control. This is the moment a normal cell starts heading down a really dangerous path.
And I love this quote from our source material because it just perfectly captures the whole idea. A cancer cell with these mutations is like a race car on a track with no speed limit. It's this powerful machine, it's built for speed, but all the safety features, the speed limits, the guardrails, the pit stops, they've all been ripped out. It just goes and goes and goes. But, and this is the key, not all mutations are created equal. This means that not all cancers are driving the same model of race car. Some are like these incredible Formula One cars, while others are more like go-karts. The specific mutation is what determines the speed, which we can really see when we look at a few real-world examples.
All right, so this chart gives us a great snapshot of that whole spectrum. At one end, you've got pancreatic cancer. This one is often driven by what some researchers call super-fast mutations in genes like KRAS or the tumor suppressor P53, and that makes it incredibly aggressive and really, really tough to treat. Then, somewhere in the middle, you have some types of breast cancer. They tend to grow more slowly, which can open up a much wider window for detection. But then, at the far end of the spectrum, we find something truly counterintuitive.
Get this, because this fact really challenges how a lot of us think about a cancer diagnosis. Some thyroid cancers grow so incredibly slowly, the doctors might actually opt for what they call active surveillance instead of immediate aggressive treatment. The body can, in some cases, pretty much keep it in check over a very long time. It just completely reframes that idea that all cancer is an immediate, desperate race against time.
So, the big takeaway here is this: the fight against cancer isn't always a high-speed chase. The whole idea of a single, monolithic disease just called cancer is pretty misleading. What we're really looking at is a whole spectrum of conditions, and each one is moving at its own pace, dictated by its own unique genetic makeup.
Okay, so let's connect all the dots. It all starts with a genetic mutation that turns a regular cell into a rule breaker. Then, that specific mutation is what sets the speed of the cancer. This creates that vast spectrum we talked about, right? From the aggressive sprint of pancreatic cancer all the way to the slow crawl of some thyroid cancers. And crucially, knowing that speed is what lets doctors choose the right strategy, whether that means hitting it hard and fast or patient observation. It really proves this is not a one-size-fits-all fight.
And that brings us to our final, and I think most important question. If cancer isn't always a race against the clock, how should we rethink the fight against it? It completely shifts the focus from just a brute force battle to a much more strategic one. It allows for personalized treatments that are tailored to the specific opponent. And yeah, sometimes that's going to mean aggressive therapy, but other times it might mean patient observation. It really forces us to look past the scary label of cancer and to understand the unique enemy within. That's a powerful idea to think about. Thanks so much for joining us.